Hey guys, hi and welcome to the video. First of all, I hope you guys are enjoying my Kubernetes series, right? I had made some 5 tutorials. This video is gonna be really amazing. I'm gonna be showing you load balancing with Kubernetes. How can we essentially route the traffic to pod 1, pod 2, pod 3, pod 4? So we do, load balancing with Kubernetes, right? Not only that, how can I scale up my pods, right? I want to have like 20 pods. I want to have 10 replicas of my backend services. How to scale up, how to scale down, right? We're going to do that, all of that in this video. This is rather an application video, so I'm gonna focus on, I have the code because I can't do everything in one video. So I'm gonna show you how I've done. And then of course, remember in the upcoming videos, as we keep progressing, I'm gonna add Prometheus on that. So we're gonna monitor the CPU and everything. And as soon as the CPU then goes above 50%, add more pods to it automatically. But all that is in the next video, not in this video. This video focuses on the load balancing aspects of Kubernetes. All right, let's get started. First of all, I would love to show you a diagram that will explain what we're trying to achieve. So this is the user, right? So the user will make a request to your API, right? So we have Kubernetes load balancer, yeah, right? So it's gonna make a request to the Kubernetes load balancer, and then Kubernetes load balancer will essentially route it to either pod 1 here, or it's gonna route to pod 2. So basically it's gonna do the routing. Now, so as we have studied the theory, right, now you guys should be comfortable on the concepts, right? So essentially each node can have several pods. Pods has essentially your containers, right? We talked about that in the theory part. A deployment has a replica has pod has containers, right? So all of that, we have studied everything here, right? So now what I'm leveraging here is I'm leveraging a use of triangular image. So it is an image for Flask application that has Nginx, and you can essentially scale your workers, right? So what the way this works is very interesting. So when a request comes in, it will route to your pod, right? Now in the pod also you have a WSGI worker. So either it's gonna say, okay, you know what? I'm gonna route the traffic to port X. I'm gonna route to port Y. I'm gonna route to port Z. Or if I'm gonna route to a new pod, right? So you can easily switch traffic using a load balancer, right? This is a very simple yet a robust, production ready, can easily, essentially, as I said, easily can take a lot of load, right? So I'm gonna show you a load testing as well soon, but let's go over the code. So I have app.py, which has essentially base route and health route, right? Then essentially I made a Docker file, right? From triangular base image, we did all of that. Then over here in the WSGI.ini, I defined my processes and thread. This is the part where this guy comes in, right? So I defined that, and then essentially I defined my compose file. If I want to test it locally, you could essentially do using a compose file, right? So that's that. I should have said it's fine. So now I defined my compose file, and then essentially I wrote my Kubernetes.yml file. So here essentially defined a type as deployment. Deployment can have replicas, right? So now here you can see the metadata. I gave it a name as app deploy. I gave it a label called Flask. Then specs has 3 items, as you can see, or actually 4 items. You can add more. Replica set default as 2. So I'm using 2 replicas by default, right? I'm using a strategy called rolling updates, right? You can read more about that. In the template section, this is where I define my pod configuration. So here I'm saying name of the image, right? App deploy. This is my image, right? App Docker. Then as you can see, then I'm defining the port that I'm exposing. I'm also defining liveliness probe, which means anytime a container is unhealthy or goes into a deadlock, automatically it's gonna kill the container and spin up a new pod for me. So it's doing at an interval of 2 seconds, right? Then of course here I define my service, kind as service. Again, I define my port and the name, right? And then here I'm selecting the app and the type as load balancer, right? So okay, so that's that. Now I will close this up. Now what I did is, in order to not execute commands one by one, I wrote a shell script, right? Essentially a Python script that does the job for me. So if I go to run.shell, these are the commands that I do. First I build my Docker image. Once my Docker image is built, then I say kubectl apply, deployment.yml file, and then essentially, kubectl get pod. So essentially prints everything. So all of this is great. Show me a demo, right? All right, guys, I'm excited to show you the demo. Let me first of all delete all the files. Let me go to Kubernetes and make sure I do not have any pods first. Let me hold on. Let me just remove that deployment.yaml. All right, should be gone now. Yeah, it is gone. Perfect. Now showtime, right? I want to show you, right? Let's do this. All right, so all I gotta do is I gotta say Python run deploy. Was it run? What was the file name? Run deployment, I guess. Yeah, run shell.py. So it's gonna build my Docker image. It's gonna do all the magic for me. So as you can see, it's building the Docker image and then it's deploying, right? So I should have essentially now 2 pods. As you can see, if I show you the status, both the pods are running and they both are healthy. I have one replica set, right? So now I'll easily show you by going to the route. If I go to localhost, I should see hello from Python, and then I should see slash, I can go to the health check and I should see okay. So now, oh, sorry, I zoomed in a lot. So if I go to pods and if I come here, I should be able to see the health check is also being done. So right now seems like this pod is unhealthy. As you can see, it made a request to the health and it looks like, you know, if it is unhealthy, we have seen, right, it's gonna kill the pod and it's gonna spin up a new pod for us, right? So right, so now let me show you something amazing. So I have 2 pods here, right, which are working for me. These are my backend microservices. Now say you want to scale up. All right, let's do this, right? You want to have 5 replicas. All right, so kubectl scale replicas is equal to 5 minus f deployment.yaml, and this will essentially scale my, and remember I don't have 5 pods here. Okay, so I'm gonna run this command here and just watch this. Okay, so I'll refresh this. There you go, guys. 5 replicas of my backend. Bang, like that, right? That's amazing, right? So as you can see, if I still go, my microservice is still working. It's still highly available, right? I can go to my API, so-called localhost, hello from Python, right? So that works fine as well, right? Now, as you can see, right, it is simple yet very robust, production ready backend. You can easily scale up, you can scale down based on your needs, right? I'll leave the entire source code. So if you come to my GitHub section, this should be there in learning Kubernetes, right? So if you come to repository, this should be lab number 5. So this would be lab number 5. I'll update the code shortly because I'm working locally and I wanted to give you a demo. Now let's load test this guy and see how in action. So now I'm gonna hammer this API. All right, I'm gonna make so many calls and then I'm gonna scale up and then I'm gonna show you. Okay, so all right, so I just wanted to show you the test, right? So now on Kubernetes I have 1 pod which has 1 container, and here is my Jemeter test that I'm gonna show you, and this will actually prove that adding replicas, and if you get what I'm trying to show you is see how we can scale up, right? So 500 requests per second, we are making it 5 times and then we're gonna record the results. Okay, you guys ready? So let's do this. Okay, so I'm gonna set up the test. So it's gonna do 5 iterations. So that's mean roughly about yeah. So the test is complete. 2,500 total requests. Average is 460 milliseconds. And as you can see, the error rate is 30%, right? So 30%, right? So let's take this. Let me just do it again to make sure that I have the right results, and then I can show you. We'll compare after that, adding essentially replicas, and we will scale it, right? So I'm doing it once again just to make sure that we have. Okay, so I'm gonna take a screenshot and then I'll put it in a paint. Okay, so now we do the same exercise, but I'm gonna scale my pods now. So here, as you can see, I'm gonna scale up. Now I should have 5 instances of my app. As you can see, 5 instances of my Flask backend service. Everyone is healthy. As you can see, green, right? 5 running instances. So the same test now we're gonna do, right? Same test, and let's compare and see how we get better results. So look at that, guys. Just look at that. Oh, shit, that's amazing. Not even a single error. You see how load balancer is scaling between different pods. this is absolutely insane. Okay, I mean, it's amazing. I have 5 replicas of my app, and Kubernetes is, as you can see, 0% error, 0%. So just to show you, keep that in mind. It's the same test. All I've done is increase the number of replica. Okay, so just to put it here, so you guys can see this pretty perfectly. Okay, so now we'll say here yellow. We'll say so what do you see here, right? There is a amazing, beautiful difference in the error rate. Look at this. Isn't that amazing? Response time is almost the same, 484, 468, almost similar, right? But what you see is after scaling, we were able to serve much more traffic and less errors, right? So that's the beauty of Kubernetes, right? You could easily scale up, you could scale down. I could easily add 10 more replicas if I need. For example, okay, you need more? All right, let's do this. So how much do you need? 10? All right, I'll add 10 instance now. Look at that. So I'll just show you on the UI. Okay. So guys, look at that, 10 instance of your app. That's amazing, right? So if I go to workload, I should have 10 running instance of my backend, and Kubernetes should do a load balancing. It will switch the traffic to either pod 1, pod 2, pod 3, pod 4, pod 5 automatically. Amazing, right? So I hope this fascinates you. I hope this motivates you. That's the power of Kubernetes, right? I'm also not an expert in Kubernetes. I have started exploring more and more and more, but just to show you the big picture of Kubernetes, right? Thank you so much for watching. I'll see you guys in the upcoming